Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to talk about time. Time, about which I often say that time is just like money. The less we have it, the more wisely we spend it. Instead of going into the philosophical details of time, let us just concentrate on how time management is done on Unix machines. Well, in an operating system, we are normally interested in two kinds of time. Let me open the man page of time from chapter 7. These two kinds of times are the real time and the process time. Well, the real time is defined as the time measured from some fixed point, either from some standard point in the past, for example, the Hijri calendar, which measures time from the year of Hijrat, the Gregorian calendar, which measures time from the birth of year of Jesus Christ, represented by AD, Anno Domini, which is a Latin word which means in the year of Jesus Christ, and maybe the Unix calendar. There is another category of real time, that is the elapsed time. This is a time measured from some point in the life of a running process. It is normally used to answer questions like how fast does program A runs on machine X, which might be asked by a programmer trying to optimize the performance of his program, and may be asked by a customer trying to decide which machine he or she is to buy. The second category is the process time, which is defined as the amount of CPU time used by a process. You might have used the time command, which is used to determine the amount of CPU time consumed during the execution of a program, given in three different values, that is the time spent execution in the user mode, time spent executing in the kernel mode, and the real mode. Let me see if this page says something about the Unix epoch as well. Well, gentlemen, as far as the Unix calendar which I talked about, its reference point is Unix epoch, which is midnight 1st January 1970. Regardless of geographic location, all Unix systems represent time internally as number of seconds passed since Unix epoch. Linux kernel saves these seconds in a 32-bit variable time_t. You can see the date and the number of seconds passed since Unix epoch, continuously increasing. The maximum value which can be there in the 31 bits are 2147, 483, 646. So these are this is the maximum number which can be stored in a 32-bit signed number. Once this value will cross this value, since it is a signed number, it will wrap to a value of minus probably something like this. And this will be representing a date of 13 December 1901. So that means there is a theoretical 2038 problem in Unix. 2038 problem in all Unix machines. When the signed number used by Dennis Ritchie, which is time_t, will overflow, and the dates inside all the Unix machines working on 32 bits will give a date of 1901 instead of 2038. Well, anyway, let me show you another man page, RTC, real-time clock. Gentlemen, there are two types of clocks that are managed by Linux systems. One is known as the real-time clock and the other is known as the system clock. The hardware clock is also called the real-time clock or the BIOS clock or the CMOS clock. It is battery operated and keeps track of the time when the system is turned off as well. On the contrary, the system clock is something else. It is a software clock, also called the kernel clock. It is managed by the timer interrupt. This actually maintains the number of seconds passed since Unix epoch. A key difference between the real-time clock and the system clock is that once the system is down, the system clock is not working. However, the battery-operated real-time clock on the motherboard is ticking. And when a system boots, the system clock has to be initialized from either the hardware clock or maybe some external source. If you want to view the hardware clock, you can use the command hardware clock. And if you want to view the system clock, you can use the command date. So we have already seen date. Let me use command hardware clock as well. Probably I need to be root for using this command. So you can see these are the two clocks. You might see a bit of difference between the system clock and the hardware clock. If your system is up and running continuously for let's suppose a month or so, which is a normal case for the server machines, you may find both clocks showing different times, and they may be away from the real time as well. To handle them, to correct them and map them to the real time, you can use the hardware clock command. Let me see the man page of hardware clock. This is a tool used for accessing the hardware clock. It can use to display the hardware clock, set the hardware clock to a different value. It can be used to set the hardware clock from the system clock. It can be used to set the system clock from the hardware clock. It can be used to compensate the hardware clock drift. Can be used for different time zones and so on. So let me show you some commands. If you think that there is a bit of difference between both these two clocks and you think that the system clock is correct, so you can give a command to copy the system clock time to the hardware clock, like hardware clock -- sys2hc. This will copy the system clock to the hardware clock. You can see there is a very minute difference between these two right now. On the contrary, if you think that the real-time clock is correct, so you can give HC to sys, that is, copy the hardware clock to the system clock. If you want to compare the hardware clock with system clock, you can use the -C option. The -C option will refresh itself after every 10 seconds and show you a comparison between the hardware time and the system time. And you can observe that how much amount of drift exists in both these values. Students, you can always set the hardware clock to a specific date and time as well. Let me come out by pressing Ctrl C. You can set hardware clock set to a specific date, for example 2016 11th month, and let me set the date from instead of 24 to 20. So if I do something like this and I don't mention the time will be taken from the midnight. And if I want to mention the time as well, I can always mention the time, like suppose 10 10 10. So whenever you make changes like this, do not forget to set it back to whatever it was previously. So let me make it same as it was before, system clock to hardware clock. So once again you can see they are synced with each other. So gentlemen, you can always, instead of setting manually the hardware clock as well as the system clock, you can use the network time protocol to update the time on your machine. Let me do man ntpd network time protocol daemon. So this is a program which sets and maintains the system time of day in synchronism with Internet Standard Time servers. On the client side, you can use NTP date. So this is a program that sets the date and time via network time protocol. Well, students, there can be three basic strategies for managing these two clocks, the hardware clock as well as the system clock. The three strategies. The first strategy is that if your machine is connected to the internet, you can easily use the network time protocol to update the hardware clock as well as the system clock of your system. If your kernel is running in a mode that is known as the 11-minute mode, after every 11 minutes it updates its times using the NTP protocol. You can always update using the hardware clock command to measure or to estimate the drift rate, and this drift rate is normally there in a file that is at cadj time. This is the drift rate which will be there in this file, having three lines, the first line having three values. The value 1 is the systematic drift rate in seconds per day. Since I have just updated it, so its value is 0. These are the number of seconds passed since Unix epoch. This is again the same value. And finally line 3 is either UTC or local time. Excuse me. And the third is use this command adj timex. So there are three ways using which you can update your system clock and the hardware clock. Now students, after understanding the working of the two clocks managed by Unix machines, let us try to understand where this time is actually used. So before I explain where this system time is used, let me create a file. Let me say that echo learning Linux is fun with Arif, and let me put it to a file abc. And let me do ls-lu to this file abc, and let me do ls-l to this file abc, and let me do ls-lc to this file abc. You can see that this is the time which is shown, which is almost same on all these three outputs. -lu option tells us about the access time, -l tells us about the M time, and -c tells us about the status change time. We have seen this in some previous session as well. You can use stat abc as well, which shows you, along with many other information, these three times: the access time, the modification time, and the change time, which you can see the same. Let us change the access time. Let me cat abc, and let me stat abc again. Now you can see the access time is changed. The access time is now 20, 30, 55. Let me change the status change time, and we know that the status change time means the inode block is changed. Let me change the inode block by saying chown. Let me change the group of this file, faculty abc, stat abc. So now you can see that the group of this file is changed. Its access time was same, that was the time when cat ran. The modification time is the oldest, that was the time when this file was created. And this is the change time, which happens when I carry out this command, chown command. So let me sum up by saying that whenever we create a file using a program suppose vim, it accesses the system time to provide the three timestamps to the newly created file: access time, modify time, and the change time, which are normally the same at the time of file creation. Similarly, once I run the cat program on this file abc, the cat program reads the file and updates its last access time. And once I ran the program chown on this file abc, it updated the status change time. And these different programs get these times from the system clock. Remember, not the hardware clock, it's the system clock. Now there is a $100 question. Let us consider two persons, one in Pakistan and other in Los Angeles, America, sitting on Linux machines, and they create a file at exactly the same time. What will be the timestamps of those files? Before you answer this question, let me show you the time in these two countries. Let me set the TZ variable to Asia Karachi, and let me set the TZ variable to America, Los Angeles, ANGELES. I hope the spellings are correct. And let me run it. you can see in both these countries the time are different. Oops. Let me correct the spellings of America. Okay. Now you can see the times in both these countries are different. You can see in Pakistan we are 13 hours ahead from Los Angeles. In Los Angeles there is morning 7:34 and over here in Pakistan it is night 8:34. Now, can anyone answer my question? Let me repeat. Two persons, one in Pakistan, one in America, created a file at the same time. What timestamps will be saved? Yes, you are right. Unix stores time as number of seconds passed since Unix epoch, which is same everywhere. So the timestamps saved will be the same. However, once you write date or ls-l over here, it will give a different output, and once the user in America gets the attributes of that file, he will get a different output. Here comes the concept of time zones. Now the problem is noon, that is when the sun is at the highest point, noon happens at different times in different parts of the world. Therefore, the different parts of the world are divided into different time zones. Well, students, different countries and sometimes different regions within a single country work on different time zones. And the information about time zone is normally kept in files in standard formats. On most of the Linux machines, these files are kept in USR share zone info directory. Right now I am in USR share zone info, and if I do ls, you can see a lot of files and directories over here. Excuse me. Now every file in this directory contains information about time zones of a particular country or a region. For example, EST is US Eastern Standard Time. CET is Central European Time. GMT is Greenwich Mean Time. And if I jump inside Asia and do an ls over here, you can find Karachi, you can find Calcutta, Dubai, Kabul. There are a lot of files over here. Okay, let me see Karachi. Over here we have the Karachi file. Let me cat this file. Oops. Once I cat this file, I cannot read most of the things over here. So let us view the format of these files by tz file. Let's see the man page from chapter 5 about the time zone file. I'm saying to the man page, tell me information about the time zone file. So this is the information about the time zone file. It tells you details of how this file is managed. And the magic 4-byte sequence tzif basically identifies that this is the time zone file. tzif, and you can see tzif, all these files start with these 4 bytes. There is a program zdump that can be used to read these files. Let me read zdump Karachi. Let me do zdump Calcutta. So you can see the time in Pakistan is over here 15:38, and the time in Calcutta is again 15:38. Okay, Karachi. So there is some problem as far as Karachi is concerned. Let me see it again. zdump Karachi, and if I say date, my date is something else and this is showing something else. So this is probably due to some settings which I have done a bit before. Let me cat another file that is @c local time. I think there is some issue with this file. Okay, and if I zdump with this, yes, this is giving me the correct time. Okay, so gentlemen, anyway, the point to be noted is zdump is a program that can be used to read the time zone file. The time zone file cannot be read by a simple cat or less program. And there is an important file that I want to show you, that is @c local time. This file is actually a soft link. You can see it is a soft link to the current settings of USR share zone info Asia Karachi. So whenever you want to see the current time, you can read this file, and this soft link will always point to one of the files in this directory, USR share zone info. Right, students, our discussion about time zones will remain incomplete if we will not discuss the environment variable TZ. TZ is the time zone environment variable. Let me echo the value of TZ. So it is empty. If I write date, I get this date, and if I say TZ, let's suppose, is equal to Asia Dubai, and then I say date, you can see I've got the time of Dubai. This is not the time of Pakistan. Dubai is 1 hour behind us. Let me write Calcutta over here. You can see Indian Standard Time is 30 minutes ahead of us. In Pakistan we have 8:41, and in India the time is 9:11. So let me man a page to show you some information or details about the TZ variable. Remember, if the TZ variable does not appear in the environment, as was the case once I run the commands, the system time zone is used. And if the TZ variable appear in the environment, then whatever value is there in the TZ variable, that is used. And if the TZ variable appear in the environment but its value is empty, then you will get the coordinated universal time. There are two formats of the TZ variable. One is very complex, which is shown over here, and the other was very simple, which says that just write down the name of that file which was there. So one final command, that is TZ select. TZ select is used to view different time zones. TZ select will not change the time zone. You can just view the installed time zones on your machine. Let me run it for you. So it is showing you about 11 or 12 options. Let me use 4, Asia, and in 4 I have these options. Let me use Pakistan. Where is Pakistan? Over here, 34. So the following information has been given for Pakistan. You can set the TZ variable to Asia Karachi if you want to set your time zone to Pakistan. And you can set this TZ variable either on the environment and export it, or you can change it in your home directory .profile file. And if you want to come out of this program, you can just press Ctrl C. Right, gentlemen, now once you know about the time zones, remember there are different programs in our systems that make use of these time zones. And the most common program is the date program. The date program shows you the time as per the time zone you are in. So it just reads the time zone files before it displays the output on the STT out. Before I close my discussion on time zone, I will recommend that please use this command as well, time date control. This is used to control the system date and time. It's a very powerful command that you can use to adjust your system clock. You can check the status, you can set the time zones, you can list the time zones using it. You can set the time according to the network protocol daemon. Okay. So gentlemen, let me close my discussion of the time zones. And let me say that up till now, we have seen the real-time clock and the system clock in Linux. And we have seen that we can update both these clocks and we can synchronize them with each other. We have also seen that how different programs like date use the time zone information to display time according to a specific time zone. Before we close our today's session, I just want to touch upon one more important and related concept, and that is locales. Let me clear screen. Well, students, you all know that there are thousands of languages that are spoken across the world. And out of them, there is a reasonable percentage that are used on computer systems. Other than these languages, different countries have different conventions for displaying information like their currency, their time, their names, their addresses, their telephone numbers, and so on. So with all these things, managing all these things is done by what is known as locale. So locale is a subset of a user's environment that depends on language and cultural convention. Let me read it again for you. This is important. A locale is a subset of a user's environment that depends on language and cultural conventions. So students, writing programs that can be configured as part of the locale in which those programs are running and can perform I/O accordingly is known as internationalization of programs, which is a very complex topic. Like time zones, this locale information is also kept by system in standard files, in standard formats. Let me show you. As I have just said, that the zone info is there in USR shares zone info, The locale information is there in USR share locale. Over here we have seen the files which contain information about different zones, and over here if I do ls, you can find a lot of directories, and each subdirectory contains information about a particular locale. If I write down the command locale, you can see the output. It shows you different variables. For example, the language, the C type. Let me talk about some important. The numeric I mean the formatting rules for numbers other than the currency. The currency format is handled by this variable lc underscore monetary. Then you have lc underscore time. Let me show you the value of these. locale hyphen kc. Let me say lc underscore time. Oops, a lot of information. Let me take out some easier one. Name. Well, this is something less. So whether it is Mr. or Mrs. or Miss, and what is the code set? Some things which are simple and some things which are not. We talk about numeric. So decimal point, thousand separator, grouping. So a lot of information about this. So, well, gentlemen, locale tells you about a lot of variables which are set for different programs so that they can perform the I/O as per the region, as per the language, as per the cultural convention in which that program is running. Let me write man locale. So please go through this man page. It gives you a lot of information about locale. If I say locale hyphen a, so it shows you, let me do WC. It shows you that this system has a support of about 479 different locales. Almost the same information you can get from USR share I18 internationalization supported. I think it will also give you more or less about the same number of different locales. I recommend you to go to the main page of locale.ctl as well, which control the system locale and keyboard settings. Well, gentlemen, these locales, if I say the current locale, this is the current locale in which I am working right now. The first two characters, if you see, is the EN. This is the language, and it always contains two letters that represent the ISO language code. Then we have an underscore, and after that we have two more letters. These are the ISO country code. And then we have the code set that represents the character encoding set. So gentlemen, this was just a kickstart of the subject of internationalization or localization of different softwares that we write. Please dig out different ways of specifying locales to a program. I expect my operating system students that they should try to write programs that can access the current locale of the system and act accordingly. That is all, students. Hope it was informative. I wish you all the best. Happy learning and Allah Hafiz.